Hello, everyone. Welcome to this monthly webinar on Southwest drought conditions and resources. My name is Emily Elias, and I'm the director of the USDA Southwest Climate Hub. For those of you who are not familiar with this webinar series, we usually try to keep these briefings to about half an hour. These briefings highlight the current state of drought conditions across the Southwest and efforts happening in the region to help build resilience to drought conditions. These monthly 30-minute briefings began during the 2020 Southwest drought as part of the Drought Learning Network's monitoring and reporting team, and will continue as long as there is interest in this type of information and format. I'd like to acknowledge the other co-organizers of these webinars who work hard each month to make them happen, especially Joel Lisenby and Gretel Fallingstad with the National Integrated Drought Information System, or NIDIS, who were unable to join us this month. The Drought Learning Network aims to support peer-to-peer learning by linking climate service providers with resource managers and resource managers with one another to share ideas, experience, and information that increase landscape and community resilience in current and future drought. If you'd like to be part of the network, please let us know. We'd be happy to give you some more information. Before we get started, let's cover some logistics. For this webinar, everyone is muted and the webinar is being recorded. The webinar recording will be available from the NIDIS YouTube channel and the drought.gov page. The format of today's webinar will be a presentation by each of our invited experts, followed by a time for questions at the end. If you'd like to ask us a question, you can do so at any time by typing your question into the box within GoToWebinar. When you log off the webinar, you'll be asked to take an invited survey. If you have a project that you'd like to share in the future, please include that in the comment box in the survey. I'd like to welcome and introduce today's speakers. Curtis Regante is a climatologist at the National Drought Mitigation Center, where he also does research on observed trends in climate and drought. He has a background as a meteorologist studying severe storms before he ventured to the climate side of atmospheric science. In his free time, he enjoys hiking, storm chasing, and good books. So now we'll turn it over to Curtis, and he will talk to us about drought conditions and future impacts.
All right, thank you, Emily. And I'm trying to share my screen here. Can anyone see my screen?
Yeah, Curtis, I can see it. You're at the 3-month.
Yes.
Good.
Okay, very good. This isn't working quite how I'm used to other software that I've used working, but this is great now. Okay, thank you. So thank you for the introduction. So I'll just go ahead and get right into this. We're going to just do a quick update here on what current drought conditions look like in regions covered by the USDA Southwest Climate Hub, and then just a quick look at what current weather conditions are in the region. So we kind of have a couple things jumping off the map here when we look at drought on a national scale. Some of the hardest hit areas of drought right now are in kind of the south central US, especially in southeast Texas and southern portions of Louisiana, basically the western parts of the Gulf Coast. And then we have some lingering drought that's mostly longer term in nature over the Central Plains, and then some newer areas of drought, which to an extent are protracted from previous drought that had been ongoing, that's been re-emerging in parts of Arizona and New Mexico and southwest Colorado recently, owing to a pretty slow start to the southwest monsoon. Over the western part of the region in California, Nevada, and Utah, after the very wet winter conditions that we've seen, plus rainfall from the remnants of Tropical Cyclone Hillary, we've seen relatively wet conditions recently continue here, where really we just have a few areas of lingering long-term abnormal dryness and isolated moderate drought. So go ahead and just zoom in on the Southwest Climate Hub area again. So we'll go ahead and talk about Hawaii and the Pacific Islands briefly at the end as well. But kind of the two main things to point out are mostly normal or wetter than normal conditions right now across parts of Utah, Nevada, and California, with a few local exceptions. And then mostly worsening conditions recently across Arizona and New Mexico, given the quiet monsoon this year. So this is how the US Drought Monitor map has changed over the last 4 weeks. So this is the map that was valid a week ago today. So currently valid, the next one will be issued valid today, but issued on Thursday morning, compared to the map back on August 15th. So we've seen more improvement in ongoing drought conditions in parts of southern Nevada, southeast California, into kind of southwest into central portions of Utah. Whereas in that same time frame, we've seen generally either the same or kind of widespread degradations across most of central and eastern Arizona, and most of New Mexico. We've seen degradations in some cases by multiple categories, which has led us back into seeing some areas of extreme drought, at least in parts of New Mexico, I believe just in New Mexico right now. So what do precipitation data look like over the last month? So as expected, kind of across parts of the Great Basin into California, up into Idaho, we've seen well above normal precipitation for this time of year. This is using the standardized precipitation index on a 30-day time scale. For anyone here who's not familiar with that index, in effect, it's looking at rainfall or just precipitation in general over this August 18th through September 16th time period this year, and comparing that to all previous years in the record at these different weather stations, and then expressing that as something like a z-score or standard deviation. So we're seeing anomalously high moisture, and I believe mostly in reference to rainfall from Hillary over that aforementioned region. And then as you go further south and east into Arizona and New Mexico, rainfall anomalies have been a bit spottier over the last month. A few areas drier than normal, a few areas actually near normal or slightly wetter than normal. When we take into account temperature with this though, so this is the standardized precipitation evapotranspiration index. This is the same as SPI, except you're looking at reference evapotranspiration, and so you're subtracting that off from precipitation. And reference evapotranspiration is a function of temperature and latitude. What we're seeing is, especially in New Mexico, at most stations there, even in areas that have maybe seen near or above normal rainfall, temperatures have been warm enough that you're also probably seeing above normal ET rates in those same areas. So the rainfall that we've seen with the monsoon isn't necessarily keeping up with evaporation rates over the last month. And as we go over the last 3 months, that signal really jumps out in Arizona, New Mexico, where we have some spots that are looking at SPEI at or below -2, put into a drought monitor category. We're looking at kind of extreme or exceptional drought over that time period. Again, the USDM is looking at all different time periods and lots of different types of data, not just SPI and SPEI. But this gives you some indication of how unusually dry and warm the basically mid-June to mid-September period has been in Arizona and New Mexico. With that, obviously, with more widespread precipitation, that having been much less severe in other parts of the region. So we'll go ahead and look back to something about a water year. This is a 12-month SPEI. This goes back to mid-September last year. And we've seen mostly wetter and or cooler than normal conditions in California, Nevada, and Utah, and even parts of Arizona, but we're still seeing a relatively dry signal in parts of south central, southeast New Mexico, and spotty dry conditions across the rest of New Mexico. So what does this look like in more current hydrological data? So this is a 20-day average stream flow as of today, measured by different USGS sites. And so we're seeing a lot of relatively dry conditions in terms of stream flow in parts of Arizona recently, with a spottier signal in stream flow in New Mexico. Some rivers see near normal flow conditions right now, some of them still far below normal, whereas Utah, California, and Nevada have higher than normal stream flows in most areas. So getting back to the alluded to temperature anomalies earlier. So this is a 3-month evaporative demand drought index from NOAA, or EDI as it's colloquially referred to. And so in terms of, so this is a drought index that's specifically just trying to look at the ET side of your evaporative demand versus incoming precipitation index. So it doesn't account for incoming precipitation at all, but we're seeing really abnormally warm, windy, sunny, dry conditions in most of Arizona and New Mexico when you look at the last 3 months. And as you'd expect then with that, this is temperature departures from the High Plains Regional Climate Center, and you'll see temperature departures over this 3-month period going back to June 21st in the 2 to locally as high as 7 or 8 degree Fahrenheit range, especially in kind of central southeast Arizona and across most of New Mexico, especially the southern part of the state. So how does this look in soil moisture? So we have a few different soil moisture models that we look at when we're producing the US Drought Monitor. So one of them is from the NIDIS system. And this suggests that the lowest areas of soil moisture might still exist in parts of Nevada. That's probably a lingering, really long-term signal. We did have a few areas of long-term abnormal dryness and moderate drought that were left there. And we're seeing kind of an extension of the relatively pretty dry soil moisture conditions that we have here locally in Lincoln, Nebraska, across much of the kind of central plains and central high plains. That does extend then into parts of northeast New Mexico. From the GRACE product, we see a kind of similar signal, though some differences here. GRACE soil moisture suggests that perhaps you're seeing some drying with how dry conditions have been in parts of southern Arizona and in more of New Mexico than what the NLDS product was suggesting. Your root zone soil moisture suggests about the same thing. And then we are still seeing, as a function likely of some of the longer term dryness that still exists across more of the region, probably some ground, at least shallow groundwater deficits that exist really across most of southern eastern New Mexico and across parts of southeast California, southern Arizona. So across a really long term, to kind of to contextualize the wet winter we had, and then some of the rainfall from Hillary, which again is pretty unusual for this time of year. Your driest areas tend to be over the last 3 years, right now the last 36 months, kind of southern Nevada, southeast California, where we still had some lingering long-term dryness, and then central and eastern New Mexico. Going out 5 years, that dry signal in New Mexico and southeast California does go away some, but that does remain in parts of central and eastern New Mexico. And then you do still see some lingering, really long-term dryness in Northern California over the last 3 and 5 years. So in terms of reservoirs, and this is an older, I'm sorry, I thought I had replaced this map. So this map is from February 2023. I can pull up the latest data at the end, but I'll go ahead and skip that for now. So quickly moving on to the Hawaiian Islands. So that whole region right now is seeing some area, the whole state is seeing either abnormal dryness or moderate drought, with some areas of severe drought, including the western half of Maui and some of the southwestern coasts of the eastern half of Maui, of course, where we had the tragic wildfires that happened partially in regards to flash drought that was going on there. And as you look over the last 3 months, most parts of Hawaii have seen below normal precipitation. On Maui and parts of Kauai and northern parts of Oahu, we've seen some pretty significant deficits over the last 3 months. We are seeing a few spots of abnormal dryness in parts of the US affiliated Pacific Islands, particularly on Pingalap and Woche. And then somewhat unusual, we're seeing short-term moderate drought right now at American Samoa, where conditions have been really dry recently. So what time are we at here? I could go into a couple more maps if we have time, but I don't know where we're at on that. Looks like it's 2:15, so I can go ahead and take any questions here.
Yeah, Curtis, actually, you're welcome. We're going to hold questions for the end.
Okay.
Thank you for that update. That was excellent. And now we'll move on to our next presenter. Marina Skumanich is a program specialist with NIDIS and coordinator of the National Coordinated Soil Moisture Monitoring Network. This is a NIDIS-led collaborative initiative to integrate soil moisture data from around the country and develop tools and services to improve early warning on natural resource issues such as drought, flooding, wildfire risk, and agricultural and ecosystem management. Marina has a master's in environmental science policy and a bachelor's of science in chemistry. So with that, I'll turn it over to you, Marina.
Thanks very much, Emily, and hello, everybody. Really glad to be here. Emily gave a lot of the content of this first slide. So again, I'll be talking about the National Coordinated Soil Moisture Monitoring Network. And I wanted to try a little bit to focus on the Southwest. I'm going to be both sharing some information with you, but also seeking your input to complete my information so I can do a better job of representing the resources you have. See if I can advance my slide. Okay, yeah, so the National Coordinated Soil Moisture Monitoring Network, our acronym is quite unwieldy. We got that name from Congress, and it is unwieldy, but it is intended to represent the key parts of this, which is the national part, the coordinated part, soil moisture, of course, and monitoring. But overall, our mission is to deliver a coordinated, high-quality, nationwide soil moisture information system for the public good. And by public good, we don't mean just drought. We are ecumenical in terms of the hydro states, so we want to serve drought needs, flooding, agricultural management, fire risk, etc., health problems. We want to be delivering this information, ecosystem services, et cetera, to all the channels that can use it to help inform better natural resource decision making. And we do that through three key activities. These are sort of the big buckets of our focus. The first is building this network of networks, acknowledging that there are a number of state and federal mesonettes, some of them relatively long duration and all of them doing a really good job of generating data, but disparate and not connected. We want to link those together, and as we can, link their data together, I should say, and as we can bring in private and citizen science sources of soil moisture data, and then ultimately also bring in satellite and model-based data, recognizing that the more data streams we can pull together, the better our chances of capturing the complicated dynamic, which is soil moisture. But we are not just about building networks of networks. We also are really focused on building a network of people, or maybe I could say networks of people. That is all of you and others, trying to make sure that we have communication all along the data stream, from the data providers to the researchers and modelers who take that data and either do fundamental research, help us understand the world, or build tools that applications people, end users can use, all the way again to the end user community, which I assume is many of you on this call. But in any case, wherever you sit, we want you to be part of our network, because we really think that we can do the best job of delivering on useful information if we understand each other's constraints and needs, et cetera. And then finally, we are going to be supporting and funding, continuing to do so, R&D to really deliver on our ultimate goal with it, which is these real-time gridded, so across the geography, user-friendly maps and tools. But to get there, we've got a lot of questions about how best to represent soil moisture and how to understand what might be an odd measurement out of the ground. What is it telling us? So, but when we say, well, soil moisture information, we want to deliver that. What does that mean? Well, as I mentioned, our ultimate goal are these products, real-time gridded mapping and other products, decision support tools that blend as appropriate the three legs of our stool, which is in situ data, remote sense data, and modeled data. All three have very important strengths and also some handicaps. And so working together, we can actually make the stool seatable. We can sit on and rely on. But in addition to those products, which again may be the kinds of things that you all are mostly interested in, we really want to build information again all along the data pipeline. So that involves developing technical assistance materials for data providers, people that are trying to install or already have installed or trying to maintain soil moisture monitoring. We want to help create standards so that we know that the data coming from different networks can at least be comparable. We understand sort of limitations and strengths, following certain set of criteria. And in addition, whatever sensors they might use could ensure we can get intercomparability. So we want to do some standards development. And then finally, we want to make sure we're building data sets for research, not just for the tools, but research and tools, so that, again, we can advance our understanding science of the hydrological cycle in general, as well as deliver services to people on the ground needing to make decisions. And we call ourselves a soil moisture network. That's our focus. We also, of course, are focused on temperature for the various reasons that you need to know soil temperature to understand the soil moisture. But more generally, we really want to also make sure we address the metadata accompanying soil moisture, so that, for example, we can determine, well, what is the effect of that level on plants, plant available water, et cetera. Here's a snapshot of the soil moisture networks in the US, and this is not everybody, and sharp eyes will notice that, for example, we don't have Colorado CoAgMet here. I had asked for an updated version of this map and didn't quite get it in time, so I just want to acknowledge that. But you can see that overall there's a little bit uneven distribution in the Southwest. And again, acknowledging that we're not showing everything here. So take that under advisement. The dark blue, which is pretty significant, is SNOTEL, as you would all imagine. And so that's obviously a really important source through that area, but there are other lowland areas that are not necessarily so well covered. So we're gonna talk about that. I just wanted to list for you, here's where you're gonna help me, I hope, as well as I hope I'm helping you a little bit, in listing the key soil moisture resources in the Southwest. So this is my understanding, what I know about, but I'm sure I'm missing things. So any of you can start popping comments in the questions if you want, or email me separately, but want to just give a survey of these resources and talk about a few key ones. The things that are underlined all have links, and I'm going to pop those in the chat when I'm done speaking. I can't double track, but so you have those if you don't at this point. But in situ monitoring, there's a kind of again sort of a mix of things going on in the region. Some are quite exciting. SNOTEL has been literally a backbone, literally and figuratively a backbone of soil moisture monitoring, which is great. California has been for a long time working with NOAA, doing soil moisture monitoring, as well as just having started as I understand it, an effort with CAL FIRE, recognizing the benefit of soil moisture to inform fire dynamics. So that's kind of an exciting start, moving into forest monitoring. Colorado has got a couple of different basin and state level networks, but they're starting a broader organizing for the state, a statewide network. So that's very exciting, as well as Nevada and New Mexico. So 3 states in the region having new network planning activities going on. Utah has been, I would say, blessed with a dense scan network. So they have actually had good resources across the state, I think, for quite a while. And then Wyoming's also got some basin level monitoring that is going to be expanded shortly with a Corps of Engineers project in their upper northeast corner. So that's the monitoring I know about in the state. That, again, if you have more to add, let me know. We'd love to fold any of your systems into our broader effort. In terms of maps and tools, which again may be more your alt focus, each state has got some mapping projects. Other than I could not find anything Arizona and New Mexico. I might have missed something, but just want to credit you all for really making an effort to bring those kind of resources to your users and the communities to help guide as we think about drought or flooding, et cetera. What are the soil moisture conditions? I just want to highlight the Colorado drought update, which includes that plant available water mapping, which again is a little bit more useful because it's saying what this level of soil moisture in this area, what effect will it have on plants? So that's kind of, again, the direction we want to start moving. Hope I'm not taking too much time. Well, I wanted to get to this part because this is what are some national resources. Now, Curtis just presented his update for the region, and he focused on 2 soil moisture products. That's the NLDAS model and then the GRACE satellite and modeled soil moisture estimates, and those are mainstays, but we've got some other resources I want to point you to. So just as you go forward, and again, I'll put the links to these in the chat so you can access them later. But again, we want to make sure we're focusing on delivering information and resources across the data pipelines. So starting with data generation, we just published an installation protocol for in situ networks. And that's a consensus guide, national consensus guide, that I think will be a really important resource. So that's something I want to point out. In addition, we're coming up with data quality and metadata guidance documents, sort of companions to that installation protocol. How can people that are doing monitoring have a sense of what their quality is or what they should be shooting for? In terms of applications or maps, the kind of thing, again, I think many of you are interested in, we've got what we call the soil moisture products dashboard, which I'm going to show you in a second. And then this soil moisture data maps and tools pages on drought.gov. Those are access points to a number of the NLDAS, GRACE, and other models that we think can help decision making. And then finally, we just are running a number of workshops and seminars, and we have a listserv where we share information. So would like to have, if you would like to get more information about soil moisture and how it might help you or help with decision making, just email me and I can speak to that. So that's the end of my slides, but I just wanted to quickly show these 2 pages on drought.gov, well, particularly this one, the drought indicator. So our idea here is, this is a little experimental, but we wanted to create a place, and this is a kind of a dynamic within drought.gov in general. We're trying to create places where you users can come and see a range of tools together and be able to look at them side by side. All right, I'm just showing you not the best map, but let me start with Fort List. So here we've got across the top a number of different soil moisture models or data sources. And here again, you can go from one to the other. You can zoom in on an area you particularly care about, you know, Arizona, that's right, or is that Utah, and then go between the different pages, and that way compare how things are. I know I gotta go quickly. Let me just finish here. We know that sometimes these models have hiccups, and right now NLDAS is having a little bit of hiccup. I know Curtis used it, and maybe he knows that it's actually been updated. But we'll talk offline, Curtis and I, to figure out if we need to update this on soilmoisture.com. I'm sorry, on our page. But so I would like to point you to this site when you have a chance to see if that helps you with your decision making. Once you pick an area, as I did earlier, you can also download that kind of map to, you know, whatever source or need you have for that. So that's, again, really just a resource I wanted to point out. The other one, as I mentioned, was on our data maps. We have soil moisture, a series of maps, again, a somewhat same tabbing here for some different maps, but then also a gallery of other resources. So I'm going to stop there. Sorry, that was fast. And thank you for your time. And as I said, any corrections, updates, or questions you have for me, please share, either in the question box or offline.
Excellent. Thank you so much. Thanks, Marina, for that presentation. Thanks, Curtis, for your presentation. We have a few questions for you here. If anyone else has questions for our presenters, please enter them into the questions box. So Marina, this one's for you. I know a lot of precipitation monitoring efforts have a role for citizen science. And so I wonder, is there a role for citizen science in soil moisture monitoring?
So 2 answers to that question: absolutely yes, why not? And more specifically, we actually included that as one of our priorities. I didn't mention, we organized a strategy document for this National Coordinated Soil Moisture Monitoring Network. It's actually called on by Congress for us to organize, well, what are the things we need to do to deliver on this vision? And one of the things we called out was the role of citizen science. So it's going to be a part of our effort. But it's also the case that, as you can imagine, humans, people love doing different kinds of measurements, and there are a lot of people, of course, that do weather measurements. And soil is just a little more complicated, right? You just don't walk out and read a gauge. You have to do some sort of extraction or have some sort of technique to figure it out. So that's one of the research areas we have to work on. And it stands to reason that we can find some good protocols for even qualitative or categorical soil moisture characterization. And someone with experience can say, and farmers do this all the time. So it's about figuring out what the farmers do to say it's really dry now, or it's pretty dry, or it's okay, or it's pretty wet. So that's kind of the first thing we need to do, is focus on getting some sort of more straightforward approaches. And then ultimately it may be a matter of finding some cheaper and more agile soil moisture sensors that citizens can use. So we've of course got the air now, purple air kind of model in our heads. That would be great, but we're not quite there yet.
Excellent, thank you. And one more question. Have you thought about providing a multi-model observation ensemble mean map of the soil moisture data?
So I'm going to take that and carry it along. I'm sure there are researchers that have, in terms of the planning for this broader initiative. No, that hasn't been on our list, but I see the point of that. So thank you very much. I'll definitely include that.
Excellent. Well, thanks everyone. We are at time. Our next drought briefing will be October 17th at 1 Mountain Time. This webinar, this briefing was recorded and it will be posted on drought.gov. So if you missed something, you can find it there. And thanks again to Curtis Riganti with the National Drought Mitigation Center and Marina Skumanich with NIDIS for their presentations today. This concludes our September drought briefing. Thank you.